Alright, so in our last session we spoke about hierarchy flattening. How do we convert the hierarchical structures to the flat structures? And today we will go ahead with a combination of transformations, which is history preserving, table comparison, key generation, and yeah. So we will look at these three combinations. So alright, so if you look at the table comparison transformation, the first one that we will use, so it compares two data sets and produces the difference between them as a data set with rows flagged as insert, update, and delete. Alright, so this can be used as a combination with what? Map operation, because map operation reads your inserts, updates, and deletes opcodes, and it will allow you to convert those operations. Now we will see how does this table comparison work, and the history preserving transformations creates a new row only for each row flagged as update, which means whenever there is an update, instead of update it converts that into an insert, and also it will create a new flag for it saying that okay, this is a new record and it is a new flag. And key generation as a combination generates artificial key into a table starting after the maximum existing values in a table. So remember the word starting after the maximum existing key values in a table. Now if let us say key values means number of rows. If your table has 1000 entries, now if you are trying to do a new insert into a table, this will go and add 1001 for that record. So look at these three as a combination. So for us to do this activity, let us right, so I have the customer table on which we will be looking at that, and or let me add a flat file so that it will be easy for us to go and change the data. Alright, so I'm giving the name as flat file underscore history preserving underscore source, and this is a pipe delimited file. So give the pipeline symbol. It will ask you to override the schema, yes, and then skip the row headers. Since this is your source file, you have to skip the row headers, and if it is your target file, you have to write the row headers. So click on save and close, and now let me go and create a job and call this as job underscore history preserving. Under that, create a data flow, df underscore history preserving. So for you to complete this activity, you need some additional fields on the target table, and since we are also trying to do a table comparison here, table comparison always compares on a target table which is your permanent table. So it can be your target table, or you can do a table comparison on a lookup based on your scenario, but just make sure that whatever the table that you are looking up on the table comparison, it should be a permanent table, but it cannot be a template table. So we have to first go and create a permanent table with customer data, so that once we modify the data, instead of getting insert updated, it should go and get inserted. So that is the scenario that we are trying to build, where we are trying to preserve the history of the data. Now I need a permanent table as a target table for this. So right, Sorry. So I'm adding fields here that are required for this job into the target table, and then create a target table trgt underscore cust underscore demo. Put it in your target data store, connect to that. So for us to do this activity, I need some additional fields. I'll just add these columns to the output. So we need two additional columns called as valid from and valid to, because we are trying to do preserve the history of the data. So when I say preserve the history, so let us say I was in Bangalore and after that I moved to Hyderabad. So when I was in Bangalore, I'm a member of a country club, and when I moved to Bangalore, when I moved from Bangalore to Hyderabad, if they just go and update my address with Hyderabad's address, probably they will not have my history. So they should keep this old date and a new date, and they should not overwrite my record, but they should add it as a new record, so that they want to refer to my Bangalore transactions, they can do it, and they want to refer to my Hyderabad transactions, they can do it. So that is the reason why we need to have two additional dates, valid from and valid to, and I am just populating them with sysdate function, because this is just to create the structure. I am going to delete this data again and reload a fresh set when I'm doing this, and then valid from, valid to, right, another key column called as surrogate key, and I'm just populating that with generate row number. Alright, so let us run this job. We are trying to create a structure as of now. I'm just thinking that I missed one or two fields, and let us check that. So table comparison, and even before that I need this query recover last deleted. So if you delete anything by mistake, you can get it back by adding recover last delete, and I just need a valid from. So remember we spoke about the fuel example, and in that one we have a date column on which it is valid from. So we just need a valid from that should be coming in from source, based on which we can do a history preserving on the data. Then next one is a table comparison transformation. So here this table comparison does a comparison between your source dataset and your target dataset. So I'm just importing this table to be a permanent table. Did I delete, or it just went off? Okay, so just let me pull it and make it as a target. Alright, so now open the table comparison, and if you look at the graphical representation of the table comparison, it says compares two sets. One is your source set and the other one is your the set on which you want to compare. It can be a target or it can be on any fixed set on which you want to compare. So if you open the table comparison, you have the schema in, which is your input columns, and the schema out, which is your output columns, which is not yet defined, because this will be your target table structure. So this is the table space which you have to choose on which you want to compare. So this is on my target data store, and target customer demo is my table name. And by the time you select this one, it will automatically generate the output structure, which is nothing but your target table structure, and then generate a key column. So if you want to generate a key column within this table comparison transformation, you can go and choose that, but we are trying to do that using surrogate key, key generation transformation. And when you are doing a table comparison, typically, an input data set, right? A source data set is compared with your target data set, which means a record by record of your source data set is compared with your record by record of your target data set. So this record is compared with this, and then with all the records to see if it is present in that one, or if it is the same record, and it will identify if there are any new records or updates or any deletes. Now to do this activity, when we know that our input has some duplicate data, it is always good to tell the system that input contains duplicate keys if in case your input is having some duplicate data, and detect deleted rows from comparison, because inserts and updates will be captured on your target table, but deleted rows will not be captured, so you can detect them by checking this box, right? So then there are three methods of comparisons. One is row by row comparison. This is especially done when you have less volume of data. So when your source table has less number of records and your target table onto which you are comparing has less number of records, then you go by a row by row comparison. So now when I say less number of records, 3,000, 5,000 records is okay, but if you have 20,000 records or 15,000 records, you just need to make sure that you go by either a cached comparison or a sorted input comparison. So mid segment of data, or like mid-range of data, you go with a sorted comparison, which means you sort the data that is coming into the table comparison on a particular key, and then you do a table comparison that will improve the performance, right? Or the third one that goes is a cached comparison. So this will take an image of your source data, an image of your target data, and it will try to do a comparison by image. So since we have less number of records, let us go with the row by row. And here I am trying to add the customer ID into the primary key column. So let us say if you are having a a table on which only one particular column is a primary key, then you can drag and drop that column into this one. And if you have a combination of keys, like, okay, customer, for example, if you look at the plant level material information, material number and plant number, plant ID is a combination there. So if you want to utilize that kind, you can pull one more column into this one as a combination key. So these will be the primary key columns. Like on your source table, it will take the customer ID, and on your target table, it will see if this customer ID is existing, and then it will go and compare the remaining columns if there is any change or if the data is same. So compare column list will hold the remaining columns on which you want to check. So let us say if you have, if you know that your data will change only on these few columns, right? Sorry. What you can do is you can drag these few columns into compare column list. Or if you know that your data will change only on one particular column, you can just drag that one single column into the compare column list, right? Or if you don't give anything in this compare column list, which means that other than these two columns that are kept here, all the guys, is everybody not able to hear me, or just Satyaraj? Is there any problem with my voice? Am I audible, guys? Okay. Alright, Satya, can you please check your connections? Alright, so you can just drag all the columns into this box, or if you leave this box empty, compare column list, which means only the columns that are dragged into your primary key column will be ignored and all the remaining columns will be compared. So let us say I'll do there is a change in the city, address, and phone number. So these are the three columns that I'm going to change. So I'll drag and drop this into this one, and this is a filter. Let us say you don't want to do a comparison on a particular column which doesn't have a valid from entry, so you can skip that, or a country code which has a blank or a null, you can skip that. You can apply any level of filter so that you can do this comparison within that set, not on the entire table but within the valid set that you can perform. Now this is the table comparison. So table comparison compares your source and target tables, and it produces the output with opcodes, insert, delete, and discard, update. Right, compares two datasets and produces the difference between them as a dataset with rows flagged as insert, update, and delete. Right now, next one, this is pretty much similar to your map operation. Map operation directly converts your insert to update, update to delete. It will not maintain any history, but history preserving transformation, remember there is a chance that they might ask you in this interview questions. If you say that you worked with the history preserving, they'll try to confuse you between the map operation and the history preserving. The same activity can be done with the map operation too. You can convert an insert to you can convert an update to insert. But with the history preserving transformation, it will be inserted as a new row into the target, and also the history of that particular record will be preserved. Okay. Alright. So now history preserving transformation. If you open this one, it has the schema in and schema out, which is exactly the same, which is target structure. Then you have the valid from and valid to columns. And if you don't have a valid to, it will take the system's last date as a default date. And when you are using the valid to date, you can, for the old record, use valid from date of a new record, which means yesterday the price of fuel is like $1.91 a gallon. So today, if it is changed, then what I will do, I will take the yesterday's date to today's date as valid date for yesterday's record, or use one day before the valid from date. So based on your business requirement, you can do that. And there should be a new output column which I forgot to create, which is column flag, so I'm just setting it to facts. So there should be a column flag which says that which is a new record and a old record. So I'm trying to override this column because I should create that one, but I forgot. Or let me put that as a region, right, which is a column flag which says that this is a new record and this is the old record. It will not have any values there. So what I will do is set value as y if it is a new record, and if there is any conversion on the data, then I will put it as a n. And you can drag and drop the columns on which your address will change. Drag and drop them into the compare column list. Just try to validate if you have done everything correct. The next transformation that we will be looking at is a key generation transformation, which will generate a key for all the records, and whenever there is a new record, that will add it as a new record. So on the table, which is again your target table, and the column on which we want to do is a yes key, and the incremental of value is by 1. Validate, no errors found. And now let us do initial load, because when I'm creating this table, I created with some dummy columns and dummy data. So what I will do is click on the table, go to the options tab, and delete data before loading. This will delete the data from your target table. Now select the job and execute. Now this will do what? It will just go and Just a second, let me look into this. Not used in transformations, okay. Alright, still it has some errors. Cannot be used as a target node. Query, okay. Alright, so no errors found. Let us run this one. So this will delete the data from the target table and try to load it as it is with the same data set that is coming in from the source. Now it has some 92 records, and let us look at this customer ALFKI. Okay. Once again, I think I should run it with select distinct. There is some duplicate data, so let me keep this option delete data and rerun, because if not it will confuse us with the output. Okay, still there is some change here. So Maria Sharapova and Sharapova, there is a change in the data, so there's a reason why it is saying that. But okay, for one record we will go and change the data in the source, and instead of inserting that record it should go and instead of updating that record it should go and create a history of that record, which means it should insert that as a new record, and also it should go and create a valid from and valid to. So I'm changing this and then go to the source folder, inbound, source flat file, and the file is ff underscore customers. So ALFKI, or let me just go and delete this, then it will avoid some confusion. Save it. I'm trying to rerun the job just so that we will have one single record there. Alright, so now we have one single record which says it is Telangana as a city. Now I'll go and change the city to NC in the source flat file. Right, so the record that we are working on, ALFKI, and city here I gave it as Telangana. Now let me go and change that as to North Carolina. Now this is a change in the source record itself, which means if you are not doing any of these transformations, it should directly go and update the target table without adding it as a new record. So let me just go and cross check if I remove this checkbox, delete data before loading. Okay, and we change the data. I'm not doing any changes to the job, just rerunning the job. If we go and look at this data, right, I'll have two records that are ALFKI, which has my old address and also my new address. And remember, region column we have set it to the flag, column flag. So N says that it is an old record and Y says it is a new record, and a new record number is added to that particular this thing. Right. So this is how you can use this combination of transformations, right? So till now we have maximum seen 1, 2 or 3 combinations of transformations, but these are the set of transformations that you can use it as a scenario when we are trying to do an automated delta capture, right? So there is no need for you to do any changes on the data. So in future, if there is any change in the data, automatically it will go and capture that, and it will try to put that in a target table as a new record as an insert. So with this you will preserve the history of the data, and in this scenario we have also seen the activity of a table comparison transformation and also the key generation transformation. So any questions on this? Alright, so the next transformation that we will look into is map CDC. So what is the map CDC? Map change data capture. So we have some CDC source tables called as some databases that support the CDC tables. Alright, so if you look at this data is not correct, but if you look at the data, you'll have something similar to this, right? So if a record is created on a table, it is called as insert, a new row ID is added to it, then the information will be present, and if there is any change on the same record, right, a new row number will be added to it, but instead of updating the source table, they will go and add it as a new record. And department number 10. Right, likewise, if there are any inserts, updates and deletes on the data, initially every record will be an insert, and going forward if there are any changes on the data like insert, updates and deletes, all those data changes are captured with the help of two additional columns on a table called as operation and row ID. So this operation column will capture the opcodes and row ID will capture the sequence in which this data is getting converted. So for this purpose, I am just trying to put it in a notepad. And I'm saving it as right as a text file, and we will use this as a source in our data services, and we will try to use the map CDC operation. Source flat file folder, and then CDC source new is the file name. Yes, and it's a tab delimited file. Give the right delimiter, and since it is your source file, skip the row headers as yes. Save and close. Go ahead and create a job, call it as CDC map, then create a data flow, CDC map, use this as a source. So remember, whenever somebody tells you that there is a CDC table, you just need to make sure that it has two additional columns. One is the column which captures the opcode, and the second one is the order in which these opcodes are effective on the data. Now go to the transformations tab, go to map operation, go to the integrator transformation set and select the map CDC operation, drag it in, drop it into the data flow, connect it with your source and open it. And now at the bottom you see two columns like CDC columns. It says that one is the sequencing column, the column on which it is created or the sequence is updated, and the second one is the opcode column. And for comparison, if you want to do a comparison, right, or sorry, if it is not comparison, it is a group by, additional group by column. If you want to do a group by, which means let us say if you have region code, you want to do a group by within that region code. For a quick processing, you can do that, and you can apply some additional filters if you want to. Now I'm creating a table as CDC map, and then go and execute. So it's successfully completed, and now if you go and look at the data, only these records are pushed because I'll tell you the reason. Only these records have an opcode filter as high. But only these records are pushed. Inserts are captured because the target table is a template table. Now, which means your source is a CDC table which maintains the history of the entire data with an opcode, and then you can capture those opcodes and push the data into your target table, which should be your permanent table. Right, so that is if in case you have any CDC source table. Generally Oracle has CDC source tables, but very rarely you'll be using them in any projects, right? And after that, the next two transformations are the functionalities of Excel, pivot and reverse pivot, which means in Excel, if you just look at some data, right? So what I do, I can copy this row and paste it here as a paste special. And what I do, I'll do a transpose so that it gets posted in the form of a column. Adil, there is a question from you. What is that? Our CDC table with types. Sorry, I did not get your question. Can you elaborate it properly?
Like SAD type 1, type 2, type 3 package.
Yeah, there are different scenarios, like based on your type 1, type 2 and type 3, you will be using different scenarios, or in other database terms you call them as source-based CDCs or target-based CDCs, right? So based on that you can use, like, see, think about the data, think about the scenario and go and use, like, choose and pick which is the best transformation in that case. Now this is a source-based CDC where we will be using a map operation.
Yeah, that's okay. How can we load that these different types of master data?
Sorry?
These CDC data, how can we load different ways and in different types of master tables?
See, the basic reason, let us go to the CDC tables first, right? So why these tables are maintained on a database, right? And these are not general transaction tables that you'll be maintained, or general master tables where your history data will be maintained, but these are some specific tables which you maintain, the change data tables, so to ensure that your entire history is present on your source. right? And every record that you insert, update, and delete is like captured with a tag rather than getting deleted, inserted, or updated on a table, right? So these are not generally your operation tables that you'll be using in a project. Point number one. Point number two, if you want to do a migration onto this one, on these kind of tables, what we will do is initially we will take the entire dump of your table and load it into your target, and then based on the data changes, right, you will use the map operation CDC map, map CDC operation transformation, and you will schedule this job on a periodic basis so that every insert, updates and deletes, like as they get changed on your source, they will get pushed onto your target. Okay, Chandra?
Okay.
Yeah. Alright, so the next two transformations are pivot and reverse pivot. It rotates from columns to rows and rows to columns, because sometimes when we are doing some complex operations, right, so you need to you need to go and change the structure of the data for you to apply a better business rule, right, and convert it into a desired output, and then put it back into a normal structure after your calculations are done. So I've taken a very simple example here. Let me check if the flat file. So this is like some five employees data for 3 months salary, right? So we will see how it is transposed and reverse transposed using the transformation. Not generally you will need it, but just in case if you want to, tweak your data and then apply some business rules, try to achieve something new, you can do this. Data flow pivot and then go to your source. Oops. Okay, it got saved somewhere. Alright, open this one. Again, the same process, tab delimited file. Skip the row headers as yes. So it's just 5 employees with 3 months data, 3 months salary, save and close, and we will see how this transformation works. I'm also telling you not all the scenarios you will be using this transformation, so very rarely used. So look at the graphical representation. It converts the column level data into a row level data. So now the columns on which you don't want to do a conversion or a transpose, and the columns on which you want to do a transpose. Select, drag and drop them into the pivot column list, and here you have additional columns created by the system, which is pivot sequence, pivot data and pivot header. Right, so just validate and then call it into a table called as pivot. Validate this, run this one, and once the job is done, if you go and look at the data, so this 3 columns data is now converted to a row level data. Now if you look at this one, initially it used to be 3 columns like JSAL, FSAL and MSAL, January salary, February salary and March salary. Now this header is under the header, and this data is transposed to a single column. Now if you want to apply some calculations, instead of doing it on 3 different columns, you can do it on a single column, right? So that is one way in which you can use this. And this converts the column level data into a row level data. This is a pivot transformation. So reverse pivot is exactly opposite to this. I'm just renaming the job. Then add one more data flow. Reverse pivot. Connect it. Open this. Now use the pivot table as your source. Go to the transformations tab. Select the reverse pivot transformation. Connect it with your table. Now you want to undo that one, right? Whatever we did before, you want to undo that one. So same way, the columns on which you don't want to do a pivot, then here how many axes, like you converted 3 columns to rows, so you have to add 3 axis values here, right? 2 FSAL and 3 which is MSAL. Okay, and the columns like and the headers you can ignore it, but just if you validate, you'll see so many columns on the right hand side. Input must contain okay, this one. The access column, you have to mention that is the sequence number, pivot sequence in which the data is converted. Now if you go back and add one more query transformation to this one, now take the serial number and name. Then you take the data columns, not the header columns, because we don't need the header columns there, because they have just the column name, so you don't need that. You can just select the column and rename that to JSAL, FSAL, MSAL. Load that into a target table and call it as our pivot. Validate this one to see if there are any errors in the syntax, and no errors found. Now select the job, right click and run. So it will first run the pivot data flow and then it will go and run the reverse pivot data flow. Right, the job is successfully completed. Now you go and back look at the data. So it is now converted back to the normal structure. So if you have any scenario as such, like where you need to convert these columns to a single row or transpose them, and you want to put it back into a normal structure, you can use the pivot and reverse pivot transformations. Alright, so with this we complete both the integrator and platform transformation set. We are almost like, I can say 75% through the training, right? We completed integrator and platform set. Tomorrow we'll look into base match one transformation as I promised from quality. We'll look into that. And once that is done, I'll come back to our training program. Right, once the quality transformation is done, then we'll look at the management consoles. Like tomorrow, I think like half of the session, we will look at how do I identify the potential duplicates and how do you convert that into a best record using uh, base match transformation. We'll see what is a potential duplicate, how bad they are for the projects, especially for the data migrations, and how do you convert that into a best record and give it to the customer. And after that, we will start looking at the data services management console. So tomorrow half session and another one day we will be able to complete this. Okay, any questions on what we discussed so far? So once this, sorry, I was talking about the training plan. So once the administration tool, management consoles, data services, and central management console is done, we will exclusively see separate sessions on how to interact with the XML data, how to play around with XML data, and how to create a real-time job, and how to create or expose a real-time job into a web service. And after that, we'll do a quick introduction to HANA, and we will see how do we load data into SAP HANA using data services. And after that, I'll just walk you through a project. All right. So this is what we are planning for, and we are almost like 75% through the training. All right, so that's it from my end for today. If you have any questions, you can go ahead and ask your questions.
Rakesh,
Yeah.
is there any session for creating schemas like a star schema? How to create the star schema, snowflake schema? How to implement a normalization forms? Those things.
See, that is entirely on the database side. So when I say you create a star schema, right? Data ETL tool is a tool which you use to load the data into those structures, right? If you want to create some structures like a star schema, you can go ahead and create them using your data services. Like you create an employee table, a fact table, and then the dimension tables using data services, which is like nothing but a virtual schema you have to plan and then load your data according to that, so that those tables are like available on the database. But data services, this is a quite common question that I get, but data services will not allow you to go and create star and snowflake schemas directly on the database. Data services allows you to load data into a particular table. It can be your fact, it can be your dimension, or it can be your attribute table. So the backend design has to be done on the database, but not through the data services.
Because I faced so many issues, so many people asking about what is change dimension, what is normalization forms, those things.
No, no, that is like, see, generally you will get a question. So let us say if I'm taking an interview, I'm totally an SAP guy, and definitely I'll ask you a question combination with SAP and data services. But generally, if somebody is from a database background or a .NET background and they want to ask you a question, they will talk about the other things on the database side and try to, understand like or try to clarify their understanding on data services. So you can straight away tell them that data services is an ETL tool, and the database guy or the DPA will be doing all this flat and star and nested schemas or snowflake schemas on the database. Or if they give you a virtual structure on how they will be present, we can go ahead and load the data by creating those tables, right? So once these things are loaded onto the database, probably a semantic view or a universe can be created on top of it so that they get benefited with that. Yeah, change data captures and slowly changing dimensions. These are the database concepts, Satya. Uh, so They are like pretty much same when you try to handle them using data services. It is just data, whether it is a slowly changing or a rapidly changing, or you maintain the entire history of it. Based on your scenario, you can use the data services transformations. Alright guys, we'll call it a day. Thanks for joining today's session and we'll catch you in the next session. Till then, take care and have a good day and good night.